Right now, your personal data is likely being sent to third parties. Cloud services, security cameras, and smart devices all store your information on their servers, leaving you with little control and creating significant privacy risks. Photos are frequently uploaded to a server, usually because you have automatic backup on your phone, and someone else decides what happens to them. Using a cloud service, OneDrive, iCloud, Google Drive, any of those, for documents, gives another company, access to your personal or professional data. Smart devices, while useful, send data about your home and your habits to a third party. Consider a robo-vacuum. It will map your house, and it will take that map and store it on somebody else's server. Smart televisions are similar. They can and do track your viewing habits. Several large television manufacturers now make more money selling your data than they do selling you a TV. This is a video series that is all about building a private, secure compute environment for individuals and small organizations so that you are in control and you decide who gets access to your information. Some of the information you may want to let go out. Robo-vacuums are very useful and they have to talk out to work on them, but others you can substitute. You can run your own cloud server. You can run your own backup system where you keep your data. In this series, the focus is on confidentiality, so no one sees the information unless you allow it. Integrity, maintain a consistent, accurate, and trustworthiness set of data. And accessibility, you can access your data where you need it, when you need it, locally or remotely. I'll go over all of the pieces needed to provide full data control, so your data stays on your hardware and you decide who has access. Enhance security, isolate untrusted devices to protect your primary network. Provide network-level blocking of malware and adware before it can reach any of your devices. Let you pick and choose the parts you want to implement. Perhaps you just want a more secure network, or perhaps you want to have a full local compute environment. And build this environment using open source software and standard hardware for high flexibility and low cost. I've organized this series into 5 videos so you can pick what interests you. And if you just want to improve security on your basic modem, I'll touch on that at the end of this video. In the event that networking is not familiar to you, IPv4, VLAN, DNS, and DHCP don't just roll off your tongue. I'll cover the principles of networking and security in the second video. So if these don't roll off your tongue, don't worry, this video will cover the basics and I'll give you pointers to anything else you might need. Here I'll also cover the testing to see that your network is indeed doing what you want, and more importantly, not doing what you don't want. The third video will cover the network, setting up a firewall, using a router and switches, and what the differences are between routers and switches, how to build a robust network where each part can do only what you allow. And this is really the heart of a private compute environment. Here is where every piece is told, well, you can go over here, but you cannot go over there. These pieces are allowed to talk out. Those pieces are not allowed to talk out. All of those kinds of things. And this is a section where we need to spend some money. At the very least, a small computer is needed to run the firewall. It doesn't need to be new, and it certainly doesn't need to be powerful. An old desktop can do this job very nicely. Personally, I use a mini computer, sort of like this one. It could run Windows if you wanted it to, but I run a free community version of a really nice firewall software package that I recommend and that I'll go through in this video. I'll show you how to set it up step by step and customize it to your needs. This is the part that can give you privacy by running a VPN for parts of your entire network. It will let you specify what kind of data is allowed out or in to any of your devices. As an example, I have a security camera and it tries to call home every 5 minutes or so. I don't know what it's trying to do. It's trying to send something, pictures, videos. I really don't care. My security cameras are allowed to do exactly 2 things. Get the current time, and it gets that from the local NTP time server that I run. That'll be part of the network setup. And send video to my security camera server that I'll discuss later. nothing else. These are untrusted devices, and they have access to my personal information. They're taking videos around my property and trying to send it to who knows who. So I lock them down so they don't get to do that. The fourth video will look at setting up your own cloud compute environment that can include remote access, your own private web conferencing, and more. You can run your own private internal email if you want, and your private internal messaging if you want, so nobody can see it, nobody gets access to it, and you know it's only dealing with the people you trust. It can be done in Windows or Mac OS, but I prefer Linux since it's a robust OS that supports a bunch of features that are ideal for servers. Just one example, using ZFS, which is a disk file system for data integrity. That kind of a system makes sure that no disk failure or disk corruption is going to affect your data. And it's one of a bunch of features that make Linux ideal for this. If Linux is a nasty word, no need to panic. I'll go through all the steps to set up a system from scratch, and it really isn't too hard. This can be where you also run things like video servers if you want to capture and record TVs or movies for later playback, which can be really nice for home compute environment. By controlling the network, you can also extend where your own private network reaches to. It can be multiple households in your family, or satellite offices or home workers if you're running your small office environment with more than one facility. In the fifth video, I'll walk you through security cameras, keeping them off the internet, and storing, analyzing, and alerting to you as needed. If you want to have full control over your security cameras, then this might be the video for you. I'll touch on security camera software, data recording requirements, event handling in the case you want to be notified when camera events are detected. Again, I'll go through all the steps you need to follow to set it up, and recommend a free software package that I find works very nicely. So how do we start with all of this? For many people, the starting point has been supplied by their internet provider. It's usually a single box, or maybe a set of boxes that were set up by the provider. It may look something like this. This is an example of a cable modem that does everything in one box. You can see at the bottom, there's a coax input for the cable. And this box does all four things combined. It has a modem that converts the fiber or the cable to IPv4 internet, a router that's the bridge between the public IP address that your provider assigned to you and the private IP addresses that your own personal devices will be using, your computer, your cell phone, your robo-vacuum, whatever. In this example, there are those four yellow internet connectors called RJ45, in case you ever hear that term. And the router will let your computer talk over the internet. So when you plug your computer into one of those four jacks, it will be given a private IP address, and the router will let your computer talk out to the internet and will route responses back to your computer. The third thing that's put into this box in almost every Wi-Fi type of environment is a firewall. These are almost always really straightforward. No inbound initiated traffic is allowed from the internet to your computer, and all traffic is allowed outbound from your computer to the internet. And responses are actually considered part of the outbound traffic. It's the inbound initiated traffic that gets blocked. And finally, this particular box has a Wi-Fi access point built in. From an internet viewpoint, this is identical to plugging your computer into one of those yellow RJ45 jacks. It connects your computer to the internal router, and from there to the internet. The nice thing about this setup is that it's a single device, or perhaps a pair of two devices that together do these four things, that does everything that the average home computer user needs. What it doesn't offer is anything in the way of privacy and little in the way of security. That said, there are two things, if you don't want to change anything else, there are two things you could do that would improve security somewhat. First, many modems offer a guest network. This is a separate private local network that will talk to the internet, but will not allow communication between that network and your primary internal network. This way you can have your computer, your printer, your phone perhaps, in your primary network, And you have the guest network for guests, obviously, but also places where you put your IoT devices. That would be your robo vacuum, your security cameras, things of that sort. And they're still totally open to the internet. They'll be able to send anything they want to send, but at least they're not talking to your computer directly. So one of the things you might notice is that if you put your internet connected toaster, yes, that exists, on your guest network, and your internet toaster app on your phone on your internal network, you'll note they're still talking to each other, even though they're on separate networks. And the reason for that is actually the reason that you've lost your privacy. The toaster will go out on the internet from the guest network to some server, and your phone app will go out via your internal network to that same server, and there the server will basically let them communicate with each other. Notice that the server gets to see everything that your toaster is doing. They know when you're talking to it, they know when you're making toast, and they will track and record that over time, and they'll begin to see your habits. And that's true of your internet toaster, that's true of your internet refrigerator, that's true of your home vacuum cleaner, that's true of your internet television. Every one of these things is gathering every piece of data about you that it can. That'll include your location when you use it, mapping your house, looking at what's in your fridge, looking at the kind of television shows you watch. And all of those things are collected by those companies and then usually sold to data collection agencies that you've never heard of any of them, but they go and collect as much as they possibly can and sell that information to whoever can buy it. Setting up a guest network can be done from the cable modem webpage. This is a Motorola example. Usually you'll find in advanced options. And what you're really going to be looking for here is wireless. Pretty easy to find for Motorola. You want to click on wireless. And you'll note there is an option for guest, and that's what you want. So when you click on guest, you'll see that you can now set up a guest network. Here you can separately specify 2.4 and 5 gigahertz. That can be useful because some IoT devices will only work on 2.4 gigahertz, so you could basically call them differently. Or you can give them both the same name, and your device is likely going to go and figure out which one it wants. When you're in there, you'll want to enable the guest network. Give it a name that is something meaningful to you, and don't use that for the password, please. Pick something better than that. Something should be fairly easy for people to type in if you have guests, but yet somewhat unique so it won't be totally trivial to copy. And once you've done that and it's enabled, you just click on save, and it will go and save it for you and set it up. And from then on, you can assign your IoT devices or what have you to use the guest network. And you'll want to save it. And once it's done with that, you should be all set and be able to log your devices into the guest network and keep them separate from your primary network. The second thing you can do is to change what's called your DNS name service. Anytime that you use your computer and you go to some location, say youtube.com, there's a service called Domain Name Service, DNS for short, that's used to convert the human readable name, youtube.com, into an IP address. That'll be either IPv4 or IPv6, but it's a big, huge number, whatever it is, and that people don't remember. You remember youtube.com, not some crazy number. A DNS resolver is what's used to provide that conversion. Your modem will have been set up by the internet provider to use a DNS resolver that's supplied by your internet provider. Aside from giving your internet provider full visibility to every location you go to, every time you type in google.com, your IP provider will say, oh, you went to google.com at this time, and it'll then provide you the translation. But it will also translate every address you ask it to translate. So if you go to some website that has questionable motives and it gives you someplace that's badaddress.com, your provider's DNS resolver will say, oh yeah, absolutely, here's the translation for badaddress.com. So one really easy security feature you can do is to use a more selective DNS service. If nothing else, this provides a very simple way to improve your security. So when it asks for badaddress.com, A more selective DNS service will go say, I'm sorry, I don't know what that is, and you'll see usually an error 404. You just need to log into your modem, and your ISP provider can tell you how to do that, but often the instructions are in the username and password are printed on the bottom of the modem, so you can just go and look it up. In there, you'll basically go to a web page that is your DNS modem, your internet modem, and it will show you a bunch of settings. And one of those settings that you're usually able to change is the DNS provider. And there are several great providers that are available to you, most of which are free. And I encourage you to do a web search for recommendations, but I'll mention a few that I like. All three of these providers have a free DNS resolver to protect against malware sites. One of them also provides a paid service that blocks adult sites and spam as well. The two free ones are Quad9, which is a DNS server address of 9.9.9.9, hence the name Quad9, and Cloudflare, which is 1.1.1.1. Those both provide DNS blocking of known malware servers, which right there gives you a certain amount of additional security within your system. OpenDNS, which is the third one, will also provide a paid family service that can provide blocking of adult content and spam, as well as the malware services. Here's an example from a Motorola cable modem. Once you log into it via the web page, you'll probably want to go to advanced. They're all a little bit different, but I think this will be kind of typical. And you want to look for something that sounds like connection is a perfect guess. And if you click on that, it'll tell you all about the specific connection that you've made. And down in the options, you should find something like DNS setup. And there it is, IPv4 and IPv6 DNS servers. By default, almost every modem in the world is going to start by saying that the DNS server will be given to you by the IP provider. That will work fine, except that means your IP provider will see every request you ever do, and you'll get very little protection in the way of malware. So what you can do is disable the automatically obtained DNS server and set your own DNS servers. So if you want to use Quad9, that would be 9.9.9.9. The secondary, if you go to quad9.net, you'll see the secondary that they use. It's some crazy number. You could make it be a different one. So Cloudflare would be 1.1.1.1. It'd be a little odd to use one Cloudflare and one Quad9. Choose one or the other, I would suggest. And then if you're not using IPv6, you might want to disable that as well. And finally, click Save, give it some time, and it should go and do it for you. As a side note, even if your modem provides blocking DNS resolver, without your own firewall, there's nothing preventing a user on your network from simply changing the settings of their computer to go to whatever DNS resolver they want. So even if you've set a DNS resolver up that's trying to protect against adult content, without your own firewall, any user, something every teenager will know how to do, can simply change the DNS resolver to point to another one that will do the translations, even if you've tried to block them. If you actually want to block them effectively, you're going to need your own firewall where you can control the outgoing traffic. So you can say, you can only use my internal DNS resolver. You can't go out to any external DNS resolvers. And that's an example of where you begin to set your security up to prevent things that you don't want to have happen. There are definitely malware that can get onto your computer that will bypass your own DNS resolver and try to go to their own. So best to block it if you can. But if you only do those two things, set the DNS resolver on your modem and move your non-essential devices to a guest network, you'll have already done your organization a nice favor. For better control over security and much better control over privacy, take a look at my other videos in this series about how to go set up parts or an entire compute environment that gives you better control, privacy, and security.